All right, so happy Monday. Today is August 23rd, 2021. This is our first lesson. 1.02, we're going to solve quadratic, rational, and radical equations. All right, so I'm Dr. J. Go ahead and jump into it. Okay, we are going to need your basic algebra, distribution, combined like terms, etc. Make sure you have paper and a pencil or a pen. So all of you should have something in front of you ready to take notes and work out examples. Because you cannot learn math by just watching. You need to watch, and you also need to participate by doing these problems. One, you learn better that way, and two, it'll hopefully keep you awake. All right, rational equations. All right, so given a problem like this, we have a fraction plus another fraction equals a fraction, right? So we want to multiply this entire equation by the LCM, the lowest common multiple. Least common multiple, LCM. Now, do any of you recall how to find the LCM? Anybody in chat? Anybody in chat? How do we find LCM? Okay, I'll ask you an easier question. Which part of the fraction or equation do we have to use to find the LCM? Denominator, perfect, yeah. So a lot of us hopefully know that we want to look in the bottom portion of our fraction. It's called the denominator. So we want to use that. So we know that. What's another thing that we need to do to the denominator in order to pick out the LCM? Factor it. Perfect. Yeah, we need to factor it. Excellent. So let me ask you this. Is this portion, is that already factored, the n? I know. It is, yeah. It's trivial question. Of course it's factored. It's only one term. Yep. Is n minus 5, is that factored already? Uh-huh, yep. Is n squared minus 5n factored? No, it is not. So we need to factor it, right? So let's do that. By the way, am I too loud on mic? I can turn it down a little bit. No? Oh, it's perfect? Okay. If I'm ever too loud, because I'm looking at my LED meter and it says I'm peaking a little bit. So how do we factor n squared minus 5n? So that is a good question. How do we know it's not factored? Well, there really isn't a straight answer for that, other than we know it's not factored if you can factor it. It's probably the worst answer I've ever given in math. You know it's not factored if you can factor it more. So for example, let me write on the board here. Let's see. Okay, something very simple is, can we factor 10? How do we factor 10? Something really simple. Two times 5, yeah. So if you can make a factor tree, right? It's 2 times 5, right? Is 2 factored all the way? Yes, it's a prime factor. Is 5 factored all the way? Well, yes, it's 5 times 1. So we know 10 is not fully factored because we can factor it. It's probably a really terrible answer, but that's all I got right now for you. So looking at like n squared, right? So let's do a factor tree for n squared. Well, oops, new row doesn't like my pen. So n squared is n times n, right? And then, so that's just that term. And then, I really don't like new row. It's just 5n can factor to 5 times n, which is what it is, right? 5 times n is just 5. 5n is just 5 times n. So we know n squared and 5n are not factored because, well, you can split it up even more into prime factors. So like somebody said in chat, let me go to the next screen here. Oh, actually, I'll stay on this one. This piece isn't factored yet because you can pull out an n out of both of them. So looking at these two here, right? We can separate an n and an n from those factors. So that's how we can GCF, greatest common factor. You'll hear me use GCF a lot. We're going to GCF an n out of that binomial. Remember, just vocab words, a binomial, that means you have two terms. And terms are separated by plus and minus signs. So, for example, this is a minus sign, right? So that means there's your first term, and then here's your second term. That is a 2. So we can GCF an n out to give us n times n minus 5. Now, the reverse of factoring is distribution. So we can just check our work by quickly saying, well, is n times n squared? It is. Is n times -5 -5n? Well, it is. So we know we factored it right. Does that help? Does that help answer the question? How do we know it's not factored? Okay. Guys, you're going to find out a lot that when you ask these, seemingly maybe simple questions, and you may think they're simple, but maybe they're not. I will give a very long answer and probably say too many words when all you want to hear is like the first 5 seconds what I had to say. So sorry in advance for the rest of the year. All right, so let's go to the next page. So we talked about factoring already. And that's what we have, right? We have this denominator is factored all the way, n minus 5 is factored all the way, and n is factored all the way. So the LCM, does anybody want to take a crack at it? How do we identify what the LCM is? Looks like Noah says n times n minus 5. I would agree with you. I would agree with you. So we know that, but there's a way to do LCM. Now, when I taught grade school like a decade ago, let me show you how I did LCM, if I remember right. So let me just clear this page out. You have a yeah, I have eraser. Okay, eraser doesn't work very good. Just delete everything on this screen. Wait, can I clear this screen? I think I can. Clear page? Oh, that works. Okay. Now I know. All right. So LCM. And hopefully your teacher in whatever grade this is shows you this way, because I think it's the best way. But maybe every teacher says that. I don't know. All right. So for our three fractions, we know that, well, we know this is n times n minus 5, right? So let's write down those factors. N and n minus 5. So we're going to create these columns, okay? So here's our first fraction. Our second fraction just has n minus 5. So we want to line up these factors, right? So our second fraction has n minus 5, and then our third fraction has only n. So what you do is you line up all the factors, okay? So we could actually have 3 different factors, but in this problem we only have 2 factors. We line them up, and then all we do is we just drop them. And if we had a third one, we would drop that column too. So we drop the n, and then we drop the n minus 5. So that shows us that the LCM is n minus 5. How cool is that? Does anybody recall your teacher teaching it that way? Because that's the best way, in my opinion. Oh, well, sorry about that. Your grade school teacher doesn't know the cool stuff like me. So this is how to find LCM. Awesome. Super awesome. All right, bueno? No, not bueno? How does that show the LCM? It only showed us to write down the multiples and then find the smallest one that they have in common. So you're thinking of, so somebody says they only showed us to write down the multiples and find the smallest one they have in common. So that's the greatest common factor, similar but different than lowest common multiple. So you're just mixing up the two. So for LCM, whenever you see factors, you have to write the factor down. So n is a factor, write it down. N minus 5 is a factor, write it down. And then once you write all the factors down that appear, that's your LCM. All right. So the LCM is n minus 5, correct. The LCM is n minus 5. So what we're going to do is we're going to multiply the original problem, well, that's factored, that is, by the LCM. So we're going to multiply this entire piece by n times n minus 5. And by doing this, we're going to clear the fractions. The whole point of all of this is to clear the fractions because nobody likes fractions. You may tolerate them, but you probably don't like them. All right. Now we have to distribute this LCM to all 3 terms. So this times this fraction, this times this fraction, and then this times this fraction over here. So what happens when you do this LCM times this first fraction? What happens, which is rather nice? Yes, they cancel out. So what's left in that first term then? Just the 1. Absolutely. Oops. And so let me get my pen out. So the n and the n cancel out, and then n minus 5 and n minus 5 cancel out. So that's how you get the 1 left over. All right, everyone good so far? All right. Next, we're going to do the next fraction times n minus 5. All right, what cancels out? in the quantity n minus 5. Yep. Quantity n minus 5 cancels out. And then what's left over? 1n or n, same thing. I think I just wrote n. Oops. No, I showed the next part. Whoopsies, it's fine. We'll just do that. So you could write n or 1n. It's the same thing. Preferably just write n, right? All right, and then the last one, we do this times this fraction. All right, what cancels out here? Just the n. Yep. Does the n in the n minus 5, does that cancel out? Does this n cancel out here? Yeah, absolutely not. Absolutely not. In order to cancel out that n, it must be n minus 5, the entire quantity. Remember, factors and factors cancel out, not terms and terms, okay? It's factors, and n minus 5 is the factor. All right, so we are going to write that piece, and then what can I do next? What's my next step? What do y'all think? Distribute. Yeah, we're going to distribute. We're going to do the 6 times n and 6 times negative 5. Absolutely. And then from this point, this problem looks pretty easy. Do you agree? Mm-hmm. I agree. Let's see if y'all can beat me to the end, which you probably can. I'm pretty slow. All right, so I am going to, what did I do here? So this is my thinking, and this is, remember, there's many ways to solve problems, and how I do it and how you do it may be different. So looks like somebody wrote on the board. Let's see who did that. All right, so Brianna drew on the board. Probably an accident, right? We'll just delete that. All right, so how I did this was, remember, we want to get the n's on one side and the numbers on the other. So what do you think is a good way to do that? What should we do? There's not really a wrong answer. So subtract n both sides, and I agree with Noah. I think that's easier. And Noah, why is that easier to subtract n both sides? Or anybody? No negatives. Yeah, Rachel's right. So if we subtract n both sides, we keep n positive. Now, could I have subtracted 6n both sides to get the n's on the left? Could I have done that? Would that be okay? Yeah, it would be okay, of course. But then we have a negative n value, right? And then if you think about it, at the very end, we're going to have to divide by a negative number. So I like keeping things positive if possible. I think it looks easier. So I subtracted n on both sides. And in the same step, after I subtracted n both sides, I also added 30 to both sides. So I did two things in one, just to save extra lines. And I think this problem is simple enough. You know, we're all in pre-calc. We got our big boy and big girl pants on, right, for pre-calc. So we can do two things at once. So we subtracted n from both sides, and we also added 30 to both sides, and that's how we got to this point. What's our last step? Divide by what? Yep, divide by 5. And then that's our final answer. You also make sure you reduce 31 over 5 is already reduced, so yep. By the way, to get this out of the way now, because every year I have this problem. on your TGAs, on your notes, never, ever write your answer like this. Never say n equals 31 over 5. Never write sideways fractions. It is a pet peeve of mine. When I see that, I cringe. Never write your fractions like that. Always write your fractions top and bottom. Who writes that way? People who bake a lot. So if you bake, you write your fractions like that because on your measuring cups, like 1/2, 3/4, they write the fractions sideways like that. So if you're a baker, that's probably why you write them sideways like that, because that's what they do in the kitchen for some reason. You feel attacked, as you should. So if it's a habit, stop it, because I don't want to see it. All right, I feel better now. Now, with that said, you still might see the sideways fractions in maybe math books, but it's no math book that I want to own. All right, let's go on. All right, I want everyone to try this one. Everyone do this one. So in this, what's our first goal when approaching this problem? What's the first goal? Factor it. Yes. First goal is factor the denominator. Yes. So everyone go ahead and do that. And we'll do it in parts. So I'll give you my little timer out. Let's do 1 minute, 30 seconds. I want all of you to factor. And if you can get more done in 1.5 minutes, keep going. All right. What's the factors we're dealing with? What's our LCM? People in chat. I see people are tabbed out of Neuro doing something else other than math. Not good. Remember, guys, if you're going to come to math class, make sure you're actually going to participate and listen and actively work on it. Don't just show up just to show up. 2x and x plus 1. I would agree with you. Would agree with you. All right, so we factored everything, right? And then to picking up the LCM, well, there's a 2, so we need a 2 in the LCM. There is an x, there is an x, and there's an x, so we need the x in the LCM. And then there's an x plus 1, there's an x plus 1, so we need x plus 1 in our LCM. So there's the 3 factors: 2, x, x plus 1. All right, Brianna, are you okay on factoring? Are you able to get to this right here, factoring all three fractions? Okay. So to pull up the LCM, all you have to do is just look at all of them, and then just when you see a factor, write it down. So there's an x, so write down an x. There's an x plus 1, write down x plus 1. Go to the next fraction. Well, this one has a 2, so now we need a 2, so we'll put a 2 in front, right? There's an x, we already have an x here. X plus 1, we already have an x plus 1. And then go to the next one, we have an x here, and I already wrote it down over here. So you just, whenever you see a factor, just write it down. And no duplicates. No duplicates. So even though x plus 1 appeared twice, write it down once. The x appeared 3 times, but only write it down once. The 2 only appeared once, so we always write it down once. Does that help? All right. Next, multiply. So let me give you all, let's do 30 seconds for this step. So I want you to multiply all terms by the LCM. And I went ahead and I already showed that. It's like Morella wrote on the board by accident. That's okay. Oops. All right, so in chat, when you simplify this first fraction, what do you get? Six. Everyone agree with that? Yeah, it's 6. Okay, so what about the next fraction? When you simplify that, what do you get? Well, be careful. It is a 1, yeah. So the 2 cancels out. Let me go ahead and just cross stuff off to show this. So the 2 and 2 cancel out. The x and x cancel out. And then the x plus 1 and x plus 1 cancels out. You're left with just the 1. So remember, whenever you simplify a fraction, it is impossible to get 0. If everything cancels out, it's just 1. It's the invisible 1. Okay. All right, and then that third fraction, what did all of you get? Yep. Good. Just to show that, and let me show it over here. X and x cancel out, x plus 1, x plus 1. We're left with 3 times 2, which is 6. And then over here, x and x cancel out. You're left with 1 times 2 is 2, and then your x plus 1. And then all of you are thinking here, we're going to distribute that 2. And then from here, it's pretty trivial, right? I'm just going to show the steps so we can go on. Okay, all of you from that is easily do it without me going through it. Any questions? All right, let's go on something harder. All right, rational equations. Oh, sorry, not rational, radical. What we just did was rational equations. This is radical equations. All right, not too bad. Nice thing is we don't have any fractions, right? So what we want to do is we want to get the radical isolated. We want it by itself on one side of the equation. In this example, it's already by itself. Like this radical is already all alone, and that's how we want it. Now, if I had this 3 on this side, I'd have to move it over to the left. Or if I had the b on this side, I have to move it to the left, right? Because we want the radical to be by itself. All right, so once it's by itself, we are going to square both sides. We're going to square this side and we're going to square this side. So let's take a look. Oh, and then the last piece. So note, when we get our answers, we could actually have more than one answer. We have to check our answers to make sure they are correct. Even though we get them, we say this equals this, doesn't mean they're true answers. And we'll see that in the next couple examples. All right, so we got it by itself. We are going to square both sides. Now, when I square, so here's a question for all of you in chat that are tabbed into Neuro. There's a few of you that are not tabbed in. It's like Ken, Travis, not here. Evelyn's not here. Morgan's not here. Natasha is not here. All right. Hopefully, if I call your name out, you just come flying back to Neuro and stay off your Twitter and Instagram. Anyway, when we square both sides, do we square the b and the 3 separately? Is that how we do that? No. So how do we square the left side? So this is what I'm asking you is a good question, and I'm asking it for a reason because it's a common mistake. So anybody in chat, when we square the left side, how do we square it? You square the whole term. Well, the whole piece, right? It's the whole binomial, right? The whole binomial. So when but Camille, I totally understand what you're saying. The b is a term, the 3 is a term. The quantity, the binomial b plus 3, that quantity is called a factor. All right, guys, be mindful of your tools. So make sure you don't have the pen tool selected. In the past, I have never had a problem with keeping tools active for students when they need to actually write on the board. But a lot of you are just writing on the board, and you shouldn't even have the pen tool selected. Just remember, I can see who writes where. All I gotta do is click and I can see your name. So some of you are, I don't know, getting a little crazy with those pen tools. I know, accidents happen. I agree. All right. What happens when we square a square root? When you square a square root, what happens? They cancel out. So everything inside carries down. Yep. All right. Now, how do we square a binomial? Camille, couldn't have said it better myself. You FOIL it. So you have to write it twice and you have to FOIL it. So a common mistake that people make is they think they can distribute this power to both terms. That is an illegal math operation. You cannot square the b, you cannot square the 3 separately. Remember, squaring means times itself. So you have to do b plus 3 times b plus 3. Okay? All right, Travis. All right. All right, so we FOIL it out, so everyone can do that quickly. We get b squared plus 3b plus 3b plus 9. What do we do next? Combine like terms, yep. Combine like terms. Now what? Get b to one side. So I would agree with you. However, look at this. We have, okay, so I see what you're saying. So you're saying get the b's to one side. Now, we have b squared, we have b's, we have numbers. So we want to get everything on one side, right? So what do we do to both sides to combine b's? Subtract 6b, yep. Subtract 6b, and I probably, to deal with numbers, what do we do? I did two things in one step. What should we do? So remember, let's get everything on the left side. Well, actually, there's two ways to do this. You could do it that way. So the way I did it, I subtracted 10 both sides. We could have subtracted 9 both sides and had b squared equals 1, right? Both ways would have worked, but I'm going to do it this way. All right, and then how do we solve this? So I'm just copying my work up there, right? So once I'm to this step, how do I solve b squared minus 1 equals 0? Besides moving the 1 to the other side, besides doing that. Factor, yeah, we want to solve by factor. So how does b squared minus 1 factor? It should be an easy one. How's it factor? B plus 1, B minus 1. Yep. All right. So people in this class, if that looks totally foreign to you, I would highly recommend talking to me, preferably on Skype, messaging me. But I would look up YouTube videos, Khan Academy, on factoring polynomials, factoring binomials. I am not teaching factoring in this class. So it's expected your prior skills from Algebra 1, Algebra 2, geometry, that you know how to factor polynomials. Now, I'm reviewing it, but I'm not teaching it again. Yeah, perfect squares. So, maybe on YouTube, you want to search for factoring perfect squares. You can review it in 5 or 10 minutes, super easy. But yeah, that's considered a perfect square. All right, so once we're here, what do we do? Once it's factored, what do I do to the factors? So we're going to solve by factoring, so what do I do? Set the factors equal to 0. Yes, so you remember that from last year and your freshman year? And then we solve them both, right? So we get b equals -1 and b equals +1. All right, now remember, yeah, I did say note, right? Note, we want to verify the answers that we get. So we want to plug these numbers in to our equation, the original problem here, to make sure they work. So I plug -1 and I plug +1 in, and then we just solve them, right? We solve the left side, solve the right side. So there's the work. I get 2 equals 2. That's a valid answer. If your equation, if it holds true, if it's balanced, it means it's a valid answer. Now, if those numbers didn't match, it means that wouldn't be a solution. But because it works, it's valid. Same thing for the other one. We just Simplify it both sides, and we get 4 equals 4. So that number also works. So that is a valid answer. So that means that our final answer is b equals -1 and b equals +1. So the square is on both. So the perfect squares, this is b squared minus 1 squared. Isn't 1 times 1 still 1? So that's why it's a difference of 2 squares. Hopefully that helps. Oh, you saw that? Okay. All right. Let's everyone try this example, please. This is a pretty simple one. It looks like we have about 17 minutes left, so let's all do this. I think you can get this done in, well, let's do 30 seconds, and then get as far as you can. How about that? Ready to go. Well, that was fast 30 seconds. All right, chat, what'd you all do first? Square both sides? Yeah. What does squaring a square root do? They cancel out? Yep, stuff carries down, okay. And then what'd y'all do? Move everything to the left, okay. So we should subtract 2 and add x. You want to agree with that? So, right. And then what'd y'all do? And you may not be past this step, so you factored it. So let me give you another 30 seconds to work from this point on. And again, if you're really weak at factoring, you shouldn't be. Oops. We need to talk and get you caught up, but you should be reviewing Khan Academy YouTube on factoring polynomials. It's a prior skill that you all should have. Oh, man. All right. People in chat, how does x squared plus x minus 2 factor? X minus 1, x plus 2. X minus 1, x minus 1. We got people are disagreeing here. So remember, in order to factor, so let me just write below it. All right, can everyone hear me okay? All right, I hit the back button on my mouse and I quit out of new row. Okay, sorry. Let's try this again. All right, when you factor those, those two numbers, they need to add to that coefficient and multiply to that number. So those two numbers, we need two numbers that multiply to -2 and add up to +1. Multiply to -2 and add to 1. Well, there's only one combination that multiplies to 2, right? 1 times 2? 1 times 2 will give us a +2, but it needs to be negative. So here's the question. Which combination will add up to +1? Is it 1 minus 2 or -1 plus 2? Which combination? 2 and -1? So +2 and -1. Is -1 plus 2, is that +1? It is. Is -1 times 2 -2? It is. So that is the correct factored form of that polynomial. That should look super familiar, right? Super familiar from way back when last school year. So again, you might want to review factoring polynomials. All right, then we set the factors equal to 0, right? And then from here, it's pretty simple. We have to plug them in to verify they work, right? Oops. So everyone quickly simplify both equations. Quickly simplify both sides. When you are finished simplifying those, give me a green check so I know that you are done, ready to go. All right, if you are not done, give me an X, so at least I know you're here. All right, some people are just not here. All right. All right, people in chat, what did you get for your answer on your first column? 1 equals 1. Anybody else? Oh, wait, no. That's the other one. Okay, yeah, that's the other one. What did y'all get for the first column? Four equals 4. -2 equals 2. 4 equals let's see. So -2 equals 2 looks like that's the majority of people. Let's take a look. So we all should have got. Did I mess up my? No, I didn't. Okay, never mind. Yeah, I'm good. Yeah, so we all should have got -2 on the left side. Everyone should have got -2 equals something. -2 equals something, right? Because we're just plugging it in, right? So left side equals -2, right? All right, and then under the radical, we got 2 minus -2. Well, what does 2 negatives become? What does 2 negatives become? Positive, yeah. And then 2 plus 2 is 4. And what's the square root of 4? Positive 2, yeah. Does negative 2 equals 2? Question mark. It does not. No. So does that mean that negative 2 is an answer? It does not. Yeah, negative 2 is not an answer. Yeah. So this is a big no, right? And then the other one, we should have got, like somebody said, 1 equals 1. So that does work, which means that is an answer. So the answer is x equals 1. How cool is that? Cooper, I hope. All right, thumbs up. I like it. All right, so this one's more challenging. We don't have time to go through this. Let me see. So let me, everyone write this one down real quick. And I'm just going to blast through the work. And then you guys can go back and just listen to the recording again and pause as needed. So I do want, this, if you can do this one, you can probably do any problem, in my opinion. But yeah, we don't have time. We got like 6 minutes left. We need like 15 to really talk about it. So write this down, and let me quickly I'll go through the work. I'll explain in words. I'm going to talk too fast for anybody to follow along, probably. That's okay. Go back, watch the recording, pause as needed, work on it, and go from there, okay? So I won't answer any questions on this problem, okay, after I go through it, just so you know. All right. For this problem, we have a square root equals a square root minus a number. And remember, our goal here is to get the radical by itself on one side. Well, the problem here is we have two radicals, and we cannot get both radicals by itself on one side because, well, we have two radicals and only one equal sign. So we have to choose which radical do you want secluded. And it's already set up this way to have this one secluded. So we'll just keep it as so, and we will square both sides. So you square both sides. Remember, so we're squaring the entire right side, right? The radical minus 1, right? We square the entire binomial. And then we have to FOIL it. Well, so I wrote it twice. Remember, squaring means times itself. So I do this entire piece, wrote it twice, and now we're going to FOIL it. This radical times this radical times -1, -1 times this radical, -1 times -1. And we FOIL it. So lots of work. And that's what we get. I get radical squared minus 1 radical minus 1 radical plus 1. We all know that squaring a square root cancels out. These are like terms, -1, this radical minus 1, this radical, they're the same. So it's like saying -1x minus 1x. So -1x minus 1x is -2x. So same idea. So that's why I have -2 radical that stuff, because they're like terms, okay? Radicals act just like variables when you're combining like terms. If it's the same radical and you're adding, subtracting them, you just add the coefficients of those radicals. So in this case, -1 plus -1 is -2. All right, next, we are going to get this radical by itself. So I want to move everything else to the other side. And that's what I do here. So first I combine like terms, right? So I have the 8 and the 1 are like terms. So I have this 8 and this 1 become 9. And then I just reorder. I put the variable first, -x, and then I have my 9, and this carries down. I am then going to add x to both sides. I'm also going to subtract 9 both sides. That's probably what I did. It is. And then I want to get remember the radical by itself. So I want to get rid of this coefficient. So this is -2 times the radical. The opposite of multiplication is division. So divide both sides by -2. And that's how we get 1 equals 1 radical 8 minus x. Just like variables, when you have a 1 in front, we don't have to write the 1. 1 radical is the same thing as saying radical. 1x is just like saying x. It's the same thing. So from here, we are going to square both sides. And really from here, it just becomes like a problem we've been doing. It's 1 squared is 1. Squaring a square root cancels out. And then from here, we just solve for x. We get 7. And then, just like previous problems, we want to plug 7 into our original problem to make sure that it works. So I use the original problem. I plug in what we think is the answer into all the x's, which I did here. And then we simplify both sides. And then there's that work. And we get 0 equals 0, which means it's a valid answer. So, that problem, required some steps, right? But, go back, rewatch this video, try working on this problem by yourself, unpause the video as needed to work through this problem. If you can do this problem, you can probably do any problem involving radicals. All right. So hopefully this was helpful. I know it seemed kind of fast. We had an entire hour, and that hour flies by. And pre-calc lessons, they're going to feel that way. It feels like an hour is not enough. Honestly, I wish I could. I wish I had an hour and a half for math class. If I had an hour and a half, I think we'd be good 95% of the time. So make sure that all of you go through the modules. I do not cover everything in those modules. I can tell you right now, I skipped like 25% of some of the content in 1.02. Read through it, work through them. I just didn't have time to cover all of it. So I kind of picked and choose important. I thought maybe the most important, the rest you can kind of read. So work through those modules. I can track of who actually spends time in them, the learn and the practice. Learn is, you learn it, obviously. Practice gives you practice problems. You need to go through those. If you want to be successful in pre-calc, you need to spend time outside of my live lessons, recorded lessons, and work through them. I can tell you, this math class is a lot harder than any previous math class you've ever taken in high school. And if you're somebody who barely just wiggles by or whatever, and you're somebody who unfortunately maybe uses photomath or some other cheating software to give you answers to pass quizzes and tests, I can tell you that might work for half this class, but if that's how you're doing it, I can promise you it's not going to work next semester in trig. It doesn't work. And if you're going to do that in this class to pass, you will not pass next semester. Promise you. And if you're a senior, you need this class to graduate. So remember, this class is optional. You don't have to take pre-calc, but you do have to take it if you want to go to a university right out of high school. If you plan on going to like a trade school or community college, you can take consumer math or something else. But if you plan on going to ASU, U of A, or out-of-state university, you need this class, and you need to pass. Also, with that said, like I said in orientation, if you get below a C this semester, you will not go on to next semester. You'll be taken out of pre-calc trig and put into consumer math, because people who just get a D is passing, but it's not enough to go on the next class. You get a D in this semester, you're not going to pass next semester, I promise you. So that's why we do that. So you need a C or higher to go on to next semester. What else? Yeah. So I'm here in the afternoon. If you need help, reach out to me. Either call me, send me, preferably on Skype, because that way I can answer you when I got a moment, and we can have one-on-one help or a group. If there's like a bunch of you that you talk to and you want to get together, like in a Class Connect session, and work on certain things, let me know. I like small groups. So I don't have to do one-on-one. I can do 5 or 10 of you. So keep that in mind if you work together. Other than that, little last closing. So quadratic equations, square roots, factoring, comparing the square. Oh, sorry, factoring. So completing the square. I skipped this. This is in your module, so make sure you go through that quadratic formula. I also skipped this. The x equals the negative b plus or minus the radical all over 2a. So I skipped that. That's in the module, and that's up to you to kind of review these two and work those problems out. So we did these two things. So rational equations, we want to look for the what? 3 words. So in rational equations, so the problems involving fractions, what do we want to look for? Anybody? The LCM, the lowest common multiple, the least common multiple. Yep. So the LCM, lowest common multiple or least common multiple. And then when doing radical equations, we want to get the blank by itself. The radical, yeah, just get the radical by itself, yeah. So you know those two things, you know how to approach these problems. All right, everyone, well, thanks for coming. And as always, I hope you learned something. See you tomorrow.